Okay, great. Good afternoon, everyone. I hope you enjoyed the really nice weather today and for the past few days. And it is great to see uh, many of you come back and committed to learning on this Sunday afternoon. We're right now gonna start our week 2 of our Python Bootcamp 2020. So before we start our course, I'd like to kind of go over our agenda for today and a lot of intro about our course leaders. So after the introduction, we're gonna learn Python Fundamental 3s from Keegan, who is a senior software architect and technical logic, and he has a lot of Python programming experience for the past. I think he has over 10 years Python programming experience from his professional and private life, and is being now and then teach and conference and courses like our boot camps. And so for today, he will teach us about the object-oriented programming and some terminologies, modules, and the packages. So after Kagan's class, we're gonna have at 2:30 a break for 10 minutes. You can drink some water and take a break. Then after that, we're gonna come back for our Python Fundamental 4 taught by Carson. So Carson is also a senior software developer and the same company as Keegan. And Carson is also the Python meetup in Calgary, PyYYC organizer. He has a lot of Python programming experience for the past years, and he also has a lot of project experience and is passionate about machine learning and robotics. And today he will also, I think I found that typo there, but today he will teaching us about the best practice in Python programming. So without further ado, I'm gonna stop sharing my screen and let Keegan start. And great.
Even you muted.
How's that?
That sounds
Doing
better.
all right? Okay,
Yep.
great. On the screen right now, there should be a document titled Week 2, Part 1, Introduction to Object-Oriented Programming. Have we got that? Yeah, okay, fantastic. Well, good afternoon, everyone. I'd like to start out by especially recognizing our course coordinators and some of the instructors today. Shinli has put together, she's done a lot of the organizing work in this course. She's done a lot of the timing and a lot of the communications with setting up the Zoom meeting. I know that some other people have helped out quite a bit as well. I know Will from Open House and GDG Edmonton has helped out with some logistics, as well as Lei and Jing. I know they've been putting some time into this. Peter, he spoke to you last week, and from what I saw, you did a great job. Carson speaking to you this afternoon about testing and some other Python best practices. Now that's fantastic. And you know, the rest of the instructors as well. These guys do a lot of great work, and they didn't have to be spending their time here. So if you appreciate the work that they're putting in, I think you should let them know that. So just some housekeeping items here. So we're going to work a little bit on object-oriented programming. We're going to finish, I'd hope to finish sometime around 2:10, 2:15, and then entertain questions for the remainder of the time. Shinli correctly pointed out that we'll have a little break after that, and then Carson's going to take over. All right. So Peter did a great job last week introducing you to basic calculations in Python. He showed you how to do some lists and some basic data structures, how to write some functions. And I've got good news for everyone. The good news is that using that set of functions that you learned last week, you can theoretically write any program that ever has been written or ever will be written. So, okay, that's pretty good news. So with the good comes the bad, though, and with the sweet comes the bitter. And we've got a little bit of a bitter pill to swallow. Theoretically, you can write all the works of Shakespeare. So on the basis of what Peter taught you last week, can you write any Python program that there ever was written? You know, there's a bit of a gap there. And that's what we're going to get into today. So just actually doing the calculations in Python, pretty easy. As soon as you start writing a program of any given size, you're going to run into an organization problem. You'll see this a little later in some of the slides. But a good Python programmer probably writes something like 20,000 lines of code a year, maybe a little more, maybe a little less, depending on the circumstances. So if you're at a company of any given size, you're working with millions of lines of code. And if you have a problem, you need to find which of those million lines of code is the problem. Now, not an easy thing to do. This is not a calculation problem. This is an organization problem. And we're going to work through some of these organization problems here together today. So our starting point is going to be a program written to solve a real life problem, a hockey pool. And we're going to first do it using only techniques that we learned last week. So I'd like to get everyone on the same starting point here. So we should be on the Colab link that Shinli sent out. How are we doing with that, everyone? Can you post to the chat if you're on that page and you're looking at it? Great. I see that people are looking good. I did see one person who said that they had some problems finding it. I just posted a link there. Wayne, is that helping you?
Yep, got it. Thanks.
All right, fantastic. So I fired this up, and about halfway down, there is a section of code titled Solved Using Techniques from Week 1. So if I hit this little play button, can everyone see this play button here that I'm hovering over? All right, I see a yes. So when I run that, I'll scroll down to the bottom of this code section and I'll see, there we go. I see some text here. It says start of season. Is it? This is our starting point for today. Okay, someone's asking to zoom in the page a bit. How's that doing? Is that helping out? Great. So is there anyone out there that's having problems getting this to run? Oh, someone's asking to get the link again here. I'll post it a second time. It's worth spending a few minutes to get this part right, because if we don't start on the same place, we're not going to get to the same destination for certain. I'll give it another 10 seconds here. Now, if you're having problems with this, there are a couple of other instructors out there. I think Dan's out there, and Carson's probably there as well. So they can probably help you out if you're having some problems. Okay, so we'll set out here. So I want to sort of set the bounds of this problem. Now, hockey pools, you know, we're all Canadians here, or many of us are Canadians, or probably most of us live in Canada at least. So we're surrounded by hockey everywhere. Some of you have been participants in a hockey pool, which is just a friendly little competition that you can play with your friends. And oh heavens, there we go. Right, so hockey pool is a friendly little competition you can play with your friends. And some of these get pretty serious. Sometimes there's a little bit of money on the line. And there are websites, commercial websites, that allow you to publish hockey pools so that everybody can participate with your friends. So I've got some rules for a hockey pool here. They are special rules. Some of them are a little bit different than you normally have, but since I built this hockey pool, I get to make the rules, and I've built them so that we have a talking point to work through for this week. So, right. So, oh heavens. So the rules of this hockey pool are laid out here. Everybody gets to choose 6 players, 3 forwards, 2 defensemen, and a goalie. Each player has a score, and the sum of the scores of the players is your score for the hockey team that you've chosen. There's a shared pool of players, and you can see the pool of players right here. It's we've got a pool of, I don't know, 20 or 30 players or something like that. So we build teams drawing from this pool of players. If one team chooses Radek Bonk, then other teams cannot choose Radek Bonk. So we've got to make sure we take into account those rules in our program here. There's some scoring for the teams, which we'll go through later. It's important to note that when a player is drafted for a team, that player is assigned a number that is unique per team. I'm sorry, it's not per team. It is that is unique across the league. So if Paris Doofus is drafted and he gets number 1, then no other players in the league are allowed to have player number 1. So that's an important point here. And hockey rule number 8 is the most important one. Rule number 8 is that the players in the league must have silly names. So for some reason, we don't know why, but all hockey players have silly names, or that's what it seems like. Now, that's sort of in keeping with Python, because Python is named after a comedy show. So I think it kind of makes sense that we have hockey players with silly names in our little demo here. And yeah, I agree, Daniel. Zemgus Girgensons that's a pretty good name. My personal favorite is Fred Sasakamoose. I think that's awesome. Great. So I'm going to scroll down here to the bottom. Right. And so there's two teams that are going to play in our demo league here. There's Keegan's Koalas, and we've got Carson's Canucks. Now Carson, he's the next presenter. So Carson and I are going to have a friendly little competition here and see who wins the league this season. Now, I think a good way to start out is for you to generate a team of your own. So just like we've got Keegan's Koalas here and we've got Carson's Canucks, we can have a third team that we'll add here. And I'll talk you through this as we add this third team just to go through some of the details. So I'm going to go ahead and copy this out here. And on my screen, I'm going to label this team Participant Penguins. There we go. Okie dokie. So we've got participant penguins here. You can add your name here to however you like. So name your team as it will. Gary, I didn't know that. I didn't know that the poor guy had passed away as a result of COVID complications. You know, this virus, it's a pretty serious thing that's affecting us all. So, well, let's hope that let's hope that not too many more people are affected. All right. So this segment of code I've built to be as readable as possible. And I've built this to only use techniques that you've learned from last week. So I created a little function here and it's called team create. And team create returns a dictionary. So if I go look at this guy, here we are. It returns a dictionary. So all dictionaries that come out of Team Create, they have four key value pairs. There's a name because every team needs a name. There's some forwards, and there's some defensemen, and there is a goalie. So according to the rules that we defined here, there are 3 forwards, there are 2 defensemen, and there is 1 goalie for every team. So this is the minimum information we need. I see there's a question in the chat about how I brought this cell up on the right. I hit the control button and then hovered over the function. And when I hit control left click, that brings up a new cell for me. Great. So every time I want to create a new team, I call this team create function. And we've got this dictionary that gets returned. So Carson's Canucks, what's the type of that variable? It is a dictionary. What's the type of participant penguins? That's also a dictionary. What's the type of Keegan's Koalas? Also a dictionary. Now every team is allowed to have 3 forwards. So we're going to create 3 forwards here. The forwards are created with this create forward function right here. So each forward has a name, they get a number, and they have some number of goals and assists. And it's going to start out at 0. Now, this is straight from the rules that we talked about at the start. This is returning another dictionary here. So it's kind of interesting because we have dictionaries inside of dictionaries here. So it's getting pretty complex, and there's a lot of nested data structures here. So we've got our forwards. Just like our forwards, we have our defensemen. We're gonna, when you create a defenseman, this function returns a name and a number. Pardon me, it takes name and number as parameters. It returns another dictionary, but this is a little bit different than the forward dictionary. The forward has goals and assists, but in hockey, it seems like that defensemen are actually scored based on the number of fights they have. And we'll also score them on the number of assists here. Returns another dictionary here. Similar to create forward and create defenseman, we've got a goalie, and this goalie, yet another dictionary. Goalies have names and numbers, and goalies are scored based on how many saves they make. All right, so that's a basic team structure that we've got here. Just to make it easier for everyone, I'm going to print out that structure so that you can see what you're dealing with. So I've just added a line here. It's going to print out Keegan's koalas, and you're going to see what the full data structure looks like. I'll run that here. And there you go. This is a dictionary representing, pardon me, Keegan's koalas. So you can see the name of my team. You can see the goalie, and the goalie has a number of, the goalie is a dictionary structure with a number of keys, name, the player number, the number of saves the player has. Same thing for the forwards. Alrighty. Is there anyone who hasn't been able to run this code? It's looking okay. So I haven't seen anything in chat here, so I'm going to continue on. I did see a question here. Oh, there's something from Lisa here. So you press play, and when you scroll down to the bottom, you see a window where you'll see text, and it might say something like start of season and the team Keegan's koalas.
Sorry, Keegan, how did you calculate the number? Like if you look at the forward, it has number 1 and 2 for each player, but then if you go up defenseman, how does the number become 4 or 3?
Yeah. I'll show you that right here. You see this function here, player number create?
Yeah.
So we'll go into this, and there's a little structure here that keeps track of what number has been assigned. So do you see this player number creator dictionary here?
Yeah.
Okay. So when you call player number create, it takes a dictionary as a parameter, and it returns the number in the dictionary and then increments the number of the dictionary.
Was it a random number assigned, or is it actually starting from 0 and then they just increment it by 1?
Yeah, it's starting from 0 and you increment it by 1. So here it starts out at 0, and then every time I create a new player, I call this player number create function, and this returns the existing number and increments the number inside the player number create structure. So that means that the first player that's created right here, this will get player number 0, this will get player number 1, 2, 3, 4, 5, and so on. Great. So,
Okay, thank you.
Yeah, you're welcome. Yeah. So there's a question I see there for Michael. You're asking me why I opted for a dictionary rather than an int. Yeah, and you're right. The reason is that integers can't store state. So let me see here. Let me see. I'll just do an annotation here. So I've got a function. I'll do this with an integer. So great, I've got a number. I can return number plus 1. Michael, are you wondering why the function doesn't look like that? Yeah, okay. So it seems like Michael's caught on, but for all of those who haven't seen it quite yet, the problem is that I can call this but this is going to return 1, and then the next time I call it, well, I have to have a number to put right here, and well, I could just put a 1 and then it would return 2, and 2, then it would return 3. But if I'm going to do this, why don't I just write the number myself? Like at that point, it would be, at that point when I create this, it would look like, whoa, holy moly, just went nuts on me. There we go. At that point, it would look like this: 0, 1, 2, 3. I don't want to assign numbers to players myself. I want the computer to assign the numbers for me, and I don't want to have to do the counting. That would be, if I did the counting myself, let's say like this perhaps, 0, 1, 2, 3, 4, 5, 6. Okay, so if I went and if I created another team and I put that team in right here, I might read down the list going 0, 1, 2, 3, 4, 5, 6, and then I might put 7, and we've just got a problem right now because 6 duplicates this number 6 down here. And according to the rules, each player is only allowed the player numbers must be unique. So I can't reuse the same number twice. And that's a mistake. I can absolutely use integers for this and manage the numbers myself, but I want the computer to do the work. And so if the computer is going to do the work for me, it needs a place to store the number, to store the current number. And so I've chosen to use a dictionary for this. And so this dictionary is keeping track of the next number that will be assigned. And this player number create function here is the thing that gives you the next number and increments it so that it's ready the next time I call it. So that means that when I call this, I'm going to get 0 if the first time I call it. I'm going to get 1, 2, 3, 4, and 5. But the code here is the same in every case. So if I copy and paste this, I can't make a mistake and accidentally assign the same number to a player twice. Cecilia, if you run out of players to put on teams, the way I have coded this, there is an exception raised. I know that Peter covered exceptions last week. And let me see here, right here, this function pop. So this takes a random player from the set. If that set is empty, you're going to get an exception and the program is going to shut down. In fact, we can do that here. So I'll demonstrate what would happen under those cases. So this line of code I've got here, it's going to try and take 1,000 players. Now that's definitely more players than I have in the pool. So if I run this, I'm expecting this to crash. And so we'll just run this and we'll see what happens. Oh, it turns red. Look at that. That's got to be bad news. Look at there. There you go. Key error. Pop from empty set. And that's true because I took all of the players out of the set. I tried to take another player from an empty set, and it won't work. In Python, when you try and take items from an empty set, it will raise a key error like we've got here. I see there's another question here. The question is about whether the player name is assigned from the top down or random. We should assume it is random. Now the reason is right here, this structure. This structure is a set. One of the characteristics of a Python set is that it does not respect order. So we should assume that when I pop players off this set, that they're coming off in essentially random order. Now it's an interesting point, but we can change that. Because if I change this into a list, now all of a sudden, the order is going to be going to be assigned bottom to top. So by definition, lists in Python, order is significant. So when we add one item to the list, it's going to go on at the end. And when I pop an item off the list, it'll also come off the end. And it will, Bob Beers is going to be the first guy out. Jonathan Chichu will be second. PyYYC Rabbit will be second, third, and so on. Yeah, there, Julie. Python does have data structures, and we're going to get into that later today. That's part of this object-oriented thing that we're going to cover here. Right now, this program is written assuming I do not have access to object-oriented Python. So I'm restricting myself to not use anything really object-oriented here. So we're going to get into that later. Alrighty. So we've got a general overview. We've got a general overview of this. Julie, you're right. I'm actually doing some really strange things here. Like there's all these dictionaries that we have, dictionaries inside of dictionaries. That's because if I don't have object-oriented structures at this point, like this is the best I can think of. Probably no one would write a Python program this way because they do have access to object-oriented programming. So what we're going to do here is we're going to take this program that is written not using object-oriented structures, and we're going to write the exact same program, but we're going to apply an object-oriented approach, and all of a sudden these structures, Julie, that you're seeing is lacking, it's going to work out better for you. It'll be very similar to Java for you. Alrighty. Great. So let me see here. Did I take out that? Did I take out that? Oh, good. I think I took out that bad code, and I think I can run this now. And I can go to the bottom, and I can see some teams. I can see Keegan's Koalas. It starts out the season with 0 points. Oh, you can also see here, by the way, because I changed the player pool from a set to a list. And now that it's a list, the players that come out of it are different. Bob Beers is number 1. Jonathan Chichu is number 2. PyYYC Rabbit is number 3, and so on. So that if I go up, look at the list here, there's Bob Beers, Jonathan Chichu, PyYYC Rabbit. So the order is significant. If I change this to a set, whoops, there we go. If I run this again, the players are going to be different. See, it's not, you didn't get Bob Beers first this time. This time it was Zdeno Chara and Zengbes Gergensen. Okie dokie. So we've reviewed this program written without an object-oriented method for it. Let's switch gears now, and let's write this using some object-oriented styles. And really, we're doing exactly the same thing. I've just proved that you can solve this problem without using object orientation. But we've got this organization issue, and that as this program scales up, it's going to become harder and harder to maintain it. So object orientation is really meant to solve two main issues. The first issue is duplication. It should reduce the amount of duplication in our program. The second problem is it's going to make things easier to write and debug because we'll be able to reason about where a problem could be. So the first problem is duplication. Now, there's actually a fair amount of duplication in this code, and one reason for that is that, see how I've got this forward create? Like I'm typing forward every time here. Forward create, forward create, forward create, forward defenseman create, forward create. I'm typing the word forward a lot. And probably I don't need to do it quite that much. If I were to go look at all the functions associated with forwards, so I've got forward create, forward score, forward add goal, forward add assist. Like, there's a lot of forwards here, and I would like to not type the word forward every time. So turns out that object orientation can save us from having to write the word, from having to write the word forward every single time. And so I'll just zoom down to the part in the code where we have that. Okay, so this second segment of code here, it's exactly the same, but this is written using an object-oriented style. In Python, class is the keyword that is used and is sort of your entryway into object-oriented programming. This should be very familiar to people who are used to Java, for example. All right, so I'm going to create a new text, a new code segment here just to illustrate this a little bit. Okay, so these two functions, these two code blocks are really, really similar. Yeah, sorry, there we go. So nameable create, this is going to create a dictionary with one key in it called name. Well, there is a thing called an object, and classes are how you create objects. You can see the class keyword here. You need to think of classes as a blueprint or a design. If you have a car, the design for that car we'll call a class. In fact, I'll just do some renaming here to make it more apparent. So this class it's like the blueprint for a car. It's not the car itself, it's the plan that is used to create the car. So I can, we've got class, we've got the design for the car. Now I actually want to create a car, and this is how we're going to do it. There you go. So I created a new car here. So this class is the design for the car. And this variable here is an object. It is an instance of the car. So the car in my driveway is not the same as the design for the car. Back at the factory, they have the design and the blueprints for the car. That's sort of the class portion. This car here, think of this as the version of the built version of the plan that exists in my driveway. Now, there's only one plan for that car, but there's many cars. So I can create a whole lot of cars, and all of these share the exact same design represented by the class here. This method, this init that you see here, this is called a constructor in many programming languages. So if you're used to Java, this is your constructor. If you're used to C++, this is a constructor. If you're used to Ruby, this is a constructor. So if I wanted to create, oh, what's this here? Hold on. There's a question I see here. Yeah, okay, Windsor, no problem. We're gonna go through that in a second here. One of the things that I really wanted to do is to make it clear the difference between the design for a car, that's what I'm going to call the class, and a built version of the car, which I will call an object. This thing here that you're seeing, this double underscore init close double underscore, this is a constructor. This is code that gets executed every time you build a new car. So here I've highlighted a function that returns a dictionary. Whoops, there you go, nameable car. Okay. So these methods here that use the class, and this method here that is a function returning a dictionary, these are very, very similar things. So every time you call nameable car, you get a new dictionary at the output. Every time you call car, you get a new object at the output. There's some syntax differences, which I'll go through here. So if I were to print car0.name, you'd get the name of the car. Down here, if I were to print car0 here, remember, is a dictionary. So I have to do a dictionary lookup to get the name attribute. This would print Mustang, and this would print Mustang. So these two things are almost exactly identical. But if it's me, I prefer the first. I prefer using classes here because when I print the name, I don't have to put quotes and I don't have to use open close brackets. So this one's less typing. I'm going to prefer this one. Now, this init method here, this is the method that is used to create variables when you start out. So just like here, we're creating a dictionary and we add a name key to the dictionary. In this init method, when we create a new object, we're going to add a name attribute to the object. This self here, in case you're wondering, that is a representation of the object. So I can add extra properties to the object, or pardon me, attributes, like so. So I can say name, let's say weight. Maybe I can add an attribute for color. So this call and this call, very, very similar, but in the case of in the case where I use the class, I'm saving myself some typing because I do not have to use these square brackets afterwards to do a dictionary lookup. How are we doing here? This is sort of a basic concept in object-oriented programming, but if you haven't done this before, this can be pretty confusing. So does anyone want to stick up their hand if they'd like me to spend a little more time on this? Oh, Dan wants me to change some of the names. Yeah, I can do that. Let me see. There we go. All right. So this init method, it's sort of a magic method in Python. Anytime that you see a method that ends in 2 underscores, you need to think there is some Python magic happening here, and this method has special meaning. So if I were to add another method to the class like this, you don't need to know what this method does. All you need to know is that, oh, it ends in a double underscore and there's some special Python meaning here. I won't go into all the details of these special functions because there's a lot of them, and I don't really want to. Well, we don't have time to go through all those right now. The point is, if you see a method that ends in a double underscore, then probably it has a very special meaning in Python, and you should look it up in the Python reference. Just in case anyone's wondering, by the way, the Python documentation at docs.python.com, it's probably some of the best language documentation out there on the internet. You should really use it. It's an important asset to you, and there are very few languages with documentation as good as Python's. So just throwing that out there. Okie dokie. So we've got some cars. We've got a car class, which represents the design for an object. And then we create some of these objects down here. So we've got these Mustangs that we've created. So we're going to take this and we're going to apply this to our code problem here. So here we've got a pool of players. And actually, I'm going to create a new code object here. There you go. We've got our pool of players like so. And we need to create some teams. So according to the rules that we have, each team has 3 forwards, 2 defensemen, and a goalie. So we're going to create a team class. And we're going to do it like this. So I want to initialize some attributes when we start things out. And we just reviewed the init method, which is how you initialize that. All right. So here we go. This is the way we created a team before we had object-oriented frameworks. Now we're going to do the same thing with object-oriented frameworks. So they have some similarities here. There we go. Okay, so at this point, this is before object-oriented style and after object-oriented style. So they have a lot of similarities. One thing you'll notice is that we don't have these quotes that are needed here. So that's one difference between these two styles. And you'll also notice when I create instance, when I create team dictionaries like so, and let's see, team 3, and you'll forgive me if I don't put in these parameters just yet. Oh, heavens. Didn't mean to execute that. Okay, so these two things are kind of equivalent here. Before object-oriented programming, after object-oriented programming. Now, I've saved a little bit of text here because you see every time I go team create, I have to type in team_create so that I know what kind of dictionary is being created. But down here in object-oriented land, I don't need to type in this team underscore every time I call the create method, because the syntax takes care of that for me. Yeah, Manny? That's right. The self argument is it's there by default. You need it in the definition. You do not need it when you instantiate the class. It's a lot like the this pointer in C++, or the this pointer in Java. So it's there, but it's implicit. Okay, so we've saved ourselves a little bit of text by avoiding the need to type in team underscore every time we create an object. So, you know, not a lot of savings at this point, but you know, this is just the first of a whole lot of steps that we're going to go through, and each small change we make improves things. So we saved ourselves a few characters. Let's go save ourselves some more. Oh, Lisa's saving me from my my typos here. There you go. All right. Right. Now, you know what? One other thing I'm going to do here. In old style, before object orienting, before we start using object-oriented programming, I'm looking at the forwards that we have here. And you can see every time I create a forward dictionary, I have to sort of prefix it with the word forward, because otherwise I don't know what kind of a dictionary I'm operating on. If I type forward, if I did not have this forward underscore here, I couldn't tell the difference between creating a forward, creating a defenseman, creating a team. You know, that's a problem. So I have to have this forward to let me know what kind of dictionary this function is built to operate on. Now, I need that for the score method as well, because you know, I need to know that this function is built to work on a forward dictionary. When I add a goal, I still need this forward underscore so that I know that this is built to operate on a forward dictionary. And same thing with add assist. You know, every time I create a new method here, I have to type this forward over and over and over again. Maybe there's hundreds of operations that I could perform on the dictionary. And I'd have to type in forward underscore every single time. I don't want to do that. I want to save myself some time so that I don't have to keep typing in forward. So I guess using this forward as an example here, I'll rework this forward, this representation of a forward in object-oriented style. So you've got team over here. I'll rework. I'll add a section of code here where I will rework the forward using object-oriented style. Yeah, here we go. Oops. Okay, so we're going to create a class. I'm going to create some attributes here. These would have been keys on a dictionary before, but we're doing them as attributes now. Okay, great. So what I've typed in so far, this is sort of the same as this forward create method here. Now I'm about to do something different though. Actually, I'll create a different method here. Add goal. Okay, so before I had object-oriented programming, I had to type in forward underscore create, forward underscore score, forward underscore add goal, forward underscore assist. If I shift to using this object-oriented style, I don't have to type in forward underscore, whatever it is anymore. Now, I can transform the code we have up here, which let's say I have to create 5 or 10 players or forwards. So I'll have forward 1. He'll be 0. And maybe forward 0, maybe he scores a goal. And if he were to score a goal, I'd end up typing in forward add goal, forward 0. Hold on here. Let's just make these variables right. So, again, I have to keep typing this forward underscore in every single time. And I'd like to save myself a few keystrokes. So having created this class, I don't have to do it the same way. I can do the same thing as we're doing here. I can do it below in fewer keystrokes. There we go. So this, oh, hold on. I missed one here. There we go. So this is fewer keystrokes than this. So, okay, so I've just improved our lives 1%, let's say. But you know what? How many fewer keystrokes is this? Maybe it's, I don't know, 30% fewer keystrokes, something like that. Well, on a large project, that's the difference between 100,000 lines of code and maybe 75,000 lines of code or 60,000 lines of code or something. That's just a lot of money that I just saved by taking out a few keystrokes here. And there's some other benefits to this as well. So we've made things a little bit better. Okay, so another thing I'd like to point out Oh, I see a question appearing here. Does Python read line by line? Ah, I see.
I mean, on the constructor, I didn't see a comma, but then if you scroll up on the function, you have to have a curly bracket and then you put comma in every single variable in the quote. Why was it like that?
Right here?
Yeah.
Yeah, yeah.
He use comma when he's not use comma.
Yeah. So it's because this is a dictionary here, and there's no structure object in Python. Classes fulfill the role of a structure in Python. So unfortunately, if I'm going to return a dictionary, I have to use dictionary syntax. These probably want to be strings. I do have to have commas after every variable. I do have to have these colons here. You know, it's not super nice. And if we use the object-oriented syntax, it's a little bit nicer for us. We do not need the commas here, 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 and so on. Is that what you're getting at there, Julia?
Yeah.
Or Julie?
Yeah. Okay, thanks.
Yeah. So we're saving a few keystrokes there as well. So, okay. So there is another benefit to using this class here. And the benefit is sort of summed up by something called encapsulation. Up here, we have these dictionaries that we return from these forward create methods. Now, that's just a raw dictionary. So anything can operate on that data. So I can write a function that goes in here and adds 10 to the number of goals. So what code is allowed to operate on forward 0? Anything. Anybody can write code that operates on a forward dictionary. And that code could be at any point in the program. When we shift to an object-oriented style, the only code that is allowed, well, if we've done things properly, the only code that is allowed to operate on this data is here inside this class. So init's allowed to operate on the data, add goal, add assist, add score. These methods are allowed to operate on this data. Anything outside of the class, like if I had a function here, forward, this method by convention is not supposed to operate on these variables because they're inside the class, and so you shouldn't touch them. And let me modify that a second. They are not allowed to change the variables inside the class. So something like this. So in Python, this is legal. You can do this, but by convention, generally we choose not to do this. So when we use classes, everything the only methods that are allowed to operate on the data are class members. So in this case, that would be add goal, add assist, and score. Now, this is really powerful because if you have a program that has 1 million lines in it, and you have a class like this one, you know that here, what do we have, 10 or 20 lines? You know that these lines are the only lines that are allowed to operate on these variables. Nothing else in the system is allowed to do that. So if there's a problem with your scoring method, it has to be inside the forward class. So if we have a bug with scoring, we just took the problem from, oh, there's a problem with scoring. I need to review 1 million lines of code to find the one line where there's an error in scoring. So instead of having to search 1 million lines without classes, with classes, now I say, oh, I know that only these 20 lines deal with the data inside the forward class. So I only need to look at those 20 lines to find the problem. So I just went from I need to search 1 million lines to I only need to search 10 or 20 lines. This property is called encapsulation, and it's because it is because this forward class ideally fully encapsulates all of the variables inside of it and all of the methods inside of it, so that if there's a problem with this class, you don't have to look outside of the class. That right there might be the single most powerful reason why you want to use object-oriented programming, because of that encapsulation. It's really, really important to have that when you're working on large programs. Okie dokie. So I'm going to zoom forward a bit here. We're running a little short on time. Okay. So we're going to cover how much time do we have here? We have another, oh gosh, we've only got another 10 minutes here. So there's two further things that we're going to try and cover. We're going to cover something called inheritance, and we're going to cover something called, we're going to cover some packages. I think we're probably going to run short on time to complete this here. So I think inheritance is going to be the more important of those two concepts. So we're going to look at inheritance in some more detail. All right, so we've talked about two major advantages that you get from using object-oriented programming. The first one is you don't have to type as much. The second is that you get this encapsulation thing. So we're going to cover something called inheritance here, which reduces the amount that you have to type. Now, if you look at the old version, the non-object-oriented version of our code, there's some methods that are duplicated and that we have to keep typing out over and over again. So add assist. Look at this add assist method. Now forwards can collect assists, but defensemen can also collect assists. Where's our defenseman object here? Here we go. Yeah, so there's a forward add assist here, but there's a defenseman add assist, and they both do almost exactly the same thing. So, but I kind of have to duplicate this method here because by convention, I've been saying that forward underscore methods operate on these forward dictionaries, and defenseman underscore methods operate on defenseman dictionaries. So, you know, despite this code being exactly the same, I've had to type it out twice. No, I don't like that. I would like to only have to type out this code once. Now, also, I've got this this name here, like this name. All of the objects here have this name, and I've had to type this over and over again. For create, there's this name that gets assigned to a name attribute. Defenseman has this name here, which gets assigned to a name key, pardon me. Goalie, same thing. And team, same thing. So all of these, I've had to type out this functionality for teams, goalies, defensemen, forwards. They all share that same bit. And it's like, I would like to share that function between them all so I don't have to keep typing it out. So there is something called inheritance that allows you to do this. So let's write out some of this using an inheritance style here. Yeah, here we go. There it is. Okay. So here I've got a forward, and I'm going to create a defenseman here. Okay, so this add assist method, I notice it's exactly the same on both of these classes. So I don't want to have to type that in twice. So we need a way to avoid this duplication. And fortunately, Python provides us the ability to do this. It is called inheritance. So I've got a forward and a defenseman class here. And I'm going to create another class called assistable. And it's going to look very similar to the other two classes. But it's only going to deal with one thing, and that's assists. Okay, so I've got this little assistable method here, pardon me, this assistable class. Now, I can now say that I want forward to inherit all the abilities that assistable has. And the syntax used for that is right here. Okay, so at this point, I'm going to remove assists from my classes, but they're not going to lose any functionality at all. There we go. All right, so now forwards. Nowhere in forwards does it have the assist attribute, and it doesn't have an add assist method. However, as soon as I create a forward, so this would be legal Python code. So right here, I'm calling this add assist method, and the Python interpreter is going to go look at the forward class, and it's going to say, nope, that's not the forward, that's not the add assist method, pardon me. Add goal, that is also not the add assist method. Score, also not the add assist method. And once it gets to the end, then it's going to go look at the list of classes right here. And it's going to look at the first one, and it's going to say, does the assistable class have an add assist method? And oh, it does look at that. And so this is going to be the method that's called. I see there's a few questions popping up here. Cecilia, can classes inherit more than one thing? Absolutely, they can. I'm going to, later on down here, there's some examples of that. Let me see. Let me find you one, Cecilia. Here you go, Cecilia. There's multiple inheritance right there. So here, the team is inheriting from both nameable and scoreable. I also see there's a question of what is the difference between class defenseman, player. I see Julie, what's the difference between class defenseman and class defenseman player sister? Ah, yes, okay. I'll return to the previous example. Right, so Julie, I think you are asking about the difference between this first class without the parentheses and this second version of forward with the parentheses. Is that right?
Yeah, I wasn't sure why on the example the defenseman takes up two different inheritance. Like if you scroll up, way up, like on a original notes, it has defenseman in a bracket. It takes two different inheritance, but then on your example, that one, it takes only one. So.
Yeah, you're right. You're absolutely right. You know what? I'll cover that right now. So
okay, thanks.
This is actually something called single inheritance, and it's called single inheritance because there is only one class here. Well, this is, so I just replaced forward. Let me see. Yeah, okay, so I just removed some duplication because both defenseman and forward had an assist method on it. But I also notice that both of them have a score method. So I can take out some extra duplication by replacing that score method. In this case here, the score methods need to be different because in the rules they're scored differently. But let's say that the score depended only on the number of assists. Well, I could write the score method like this in that case. Right. Okay, so they both have a score method. So I can take out some duplication there at that point. And I can do that by maybe creating a method, a class, pardon me, called scoreable. Okie dokie. So I'm going to adjust this a little bit here. Great. So now defenseman and forward, they no longer inherit from just one class. They inherit from two different classes, both from assistable and from scoreable. So I can eliminate this score method at this point because they're the same in both cases. So that's taking a little bit of duplication out of this. And the more duplication we can take out, the better, because there's going to be fewer lines of code. So at this point, if I executed code that looked like this, and if I were to call defenseman0, defenseman0.score, the Python interpreter would first say, okay, this is the defenseman class. I'm looking for a score method on the defenseman class. So go to the defenseman class. Is init, is this a score method? No. Add fight, is that a score method? No. Okay, go look at the classes that defenseman inherits. Go look at the classes that defenseman inherits from. The first one in the list is assistable. So it's going to go up here and look at assistable. Is init, is that a score method? No. Add assist, is that a score method? No. Okay, so it's not an assistable. So go back to this list of classes. It knows at this point that the score method is not in defenseman. It's also not in assistable. The next thing it will search is scoreable. It's going to go into the scoreable and it's going to say, is that a score method? No. Is that a score method? Yes. Execute. And it will return 2 times self.assists. And it's kind of interesting here. This class would actually error out if used on its own, because you see in the init method here, there's no assists. This would work if it was used on its own, but this would fail. So this is sort of a strange case where you could only use this method, you could only use this class if it was being used with another class that had an assist attribute on it, as assistable does here. So this is sort of a queer case that we've constructed, but that's one of the strange things about it. Great. So we've just covered single inheritance and multiple inheritance. Now we need both of those things to really understand how the program at the end is working here. And let's attend to that just now. Yeah, okay, here we go. Alrighty, so we're looking at the object-oriented version of this program here. So we've got nameable, we've got scoreable, we've got an assister, we've got a player, and player inherits from both nameable and scoreable. So right now, if we created a player object, player 0 would have an add, player 0 would have a name attribute on it. So actually, let's give it a proper name. Right, so player 0, a player object at this point has all the attributes of nameable, and a nameable has a name. It has all the attributes of scoreable, and scoreable has a score method. And later on, forwards have all the attributes of a player. So a forward has a name. It has an assist method. It has a score method. So forward inherits both from player and assistable here. Defenseman also is inheriting the attributes and methods of the same method. Goalie is also inheriting the player properties. And team likewise is inheriting all the attributes of nameable and scoreable. So I'm very conscious of the time here. This last segment has gone fairly quickly. So I think I want to stop there and take any last questions that there might be.
I have a question, if you don't mind.
Yes.
So instead of having two inheritance, passing it to, for example, to a player, can we nest the scoreable under the nameable, for example? So
yeah, we certainly can. So
yeah, sorry.
Go ahead.
Because I think on the previous example, you mentioned that when you put paths, it wouldn't work because one is not recognized the other class or something like that. But then if we nest it, would that work on that case?
Yep. We can nest it and it would work under that case. I need to find a suitable code segment here. Okay, so let me create some code. So I think you're saying something like, what did we have? I think we had a sister and what else did we have? I think we had an add assist method. I think we had a class like this, and oh heavens. And I think you are saying that you are saying that assister does not have an assists attribute and would error if you used it on its own.
Yeah.
And maybe if you had a player object like this that has assists, and you are saying something like, can you nest an assister in a player? Is that right?
Yeah, so the player would inherit a sister and or like the other way.
Yes, this would work.
Okay, cool.
And this would probably be the way, like if you were going to design a system, you would be more likely to do it this way, let's say.
Okay, thank you.
All right. I guess there's one other question I see here posted from Brian. You were wondering about the main.py that we have there. So you're skipping ahead to one of the sections now. I do have this section in here called when files get too big. Pardon me. Oh, come on. Yeah, there we go. So I do have this section called when files get too big. Maybe the title of this section should be something like when presentations get too big, because we haven't really covered this portion here. I'll give you the quickest possible view that I can of this. Everything that I've talked about so far is about classes, and all of those classes were in one solid block of text. You can't keep growing a single large block of text forever. You need to split it up into smaller components, into files. Ideally, each file would have at most perhaps 500 lines in it, or at the outside maybe 1,000 lines would be ideal. So in this section titled when files get too big, I've split up all of those classes and I've put them each into a file of their own. And those files on their own don't do anything. I have created a file called main.py, and this is sort of the thing that holds it all together. So I import all of these. These are called packages and modules. I import all of these into main.py, and main.py is sort of the entrance point to this whole program. And it's the thing that defines the teams that exist and the actions that are taken on those teams. Maybe it's add goals, add assists, or saves, or fights, or whatever it is. Yeah, Brian, sorry, I can't cover that too much at this time. If you want to drop me a message in the chat, maybe I can give you some further explanation. So just on account of the time here, pardon me?
Thank you so much. I think we probably need to start part 2. And
yeah, I think so.
I know we have a few parts, packages, and modules that's not covered. And that's the point of our course. Please go, for the attendees, please go through those notebooks and post any questions you have for Kagan in our Slack chat. And he will be able to answer your questions in there. And thank you so much, Kagan. I think that's a really, really interesting way to lay OOP and the classes. Appreciate it. Is Carson here?
Yeah, we've got to let Carson take over. He's got some great information on testing, which is another really important part of using Python here.
Totally, yeah. And kudos to you. I think you did a great job.
All right. Yeah, I think let's take about like 3 minutes break and come back at 2:51, and I'll start from there.
Kagan, if you want to keep answering questions before 2:51, please go ahead.
Yeah, sure. I'm still here if I can elaborate on some things. You know, I went through a lot of that pretty fast, and so I am sure that there will be numbers of questions on those items, and I can cover a few things if you like in the next couple of minutes.
Let's get started. Can everyone hear me all right? Okay, let me post my link so you can get. Before I get started, can everyone see my link and my notebook? Okay, awesome. All right, let's get started. So first of all, thanks a lot, Keegan, for this wonderful talk. It's a really good way of teaching everything OOP related. Mine could be a little bit dry because it's mostly like experience and a lot of text, but these are super important. So let's get started. So in this session, I'm going to cover basically three things: the testing, the type annotation, and some of the Python best practices. The first one is testing. So okay, so yes, zoom in. Does this seem better? Okay, perfect. All right, so why testing? Like, why do you even need to test your code? Well, you'll have to make sure that your code does what it's supposed to do. So the test is used to validate the output against a known response. So basically, for a known input, you should expect this out to be this output to be this value, and you should test it that the function actually return this value. You always have to make sure that your function test return the same result each time, no matter how many times it runs. What do you need to test your code? When do you need to test your code? Well, you should always test your code, as I just said. When you write any code, you should always first manually check if it's working, and then write a test to test it's actually working. Note that there's also another opposite process which is to write your test first and then write your code. This is called the test-driven development, TDD. TDD can be very effective, since by writing your test cases first, you should think about the edge cases first, and your code will produce less bugs. You should test any edge cases that you can think of. Like mishandling of the edge cases are mostly the causes of the bugs. When coming to the tests, basically there are two types of tests, the automated one and the manual testing. The manual testing is quite simple. Basically, you have to have a complete set of manual tests, and all you need to do is to make a list of all the features your application has, and the different types of input you can accept, and the expected results. However, every time you make a change to your code, you have to go through every single item in the list and check it again. The automated test, on the other hand, is to use a script to execute your test plan. So how do we do the automated testing? Well, in Python, we use the assert keyword. So basically, the first one is this. When we have assert this line, the first one is this assert keyword. And we are asserting that 1 + 2 + 3 equals to 6. And this should be 6 is the output message. So if it doesn't work, it should, for example, this one, it should output assertion error saying that it's supposed to be 6. So by converting this line into a function, we could do something like this. So this function takes two arguments, a list and a target. What we do is we sum this list of the numbers and we make sure that the sum of the list is equal to the target that we are aiming at. And when we run it, if everything works fine, it shouldn't produce anything. But if something is wrong, that's going to say assertion error, which should be 6. So that's some simple test cases. For automated testing, there are two very important concepts, unit tests and integration tests. So the unit test and integration test are two very important terminology in the world of testing. The unit test is to test a single component or function, whereas the integration test has multiple components. So for example, suppose we have a calculator that does a simple plus, minus, multiply, divide calculation. 1 minute here, my mouse is out of battery. Let me put a new battery in. So if there are any questions? Seems like we're good. Let's continue. So for example, let's say we have a calculator. We could have the following unit test where we turn on the calculator, the display works, it shows something like it's turned on. Well, basically for a calculator, it always shows it there. If we punch in some numbers, the display shows the correct numbers that are punched in. And when we test simple calculations, for example, like 1 + 1 = then it should output the correct result. And we could have the following integration test where complex calculation works. So for example, if you type in a complex calculation, 5 × 20 + 3 - 8 is supposed to output 107. I see your question, when do you use unit test versus PyTest? I will cover that later, which is here. So basically, for the automated test, we have a few different test frameworks. The first one is unit test, which is built into Python's standard library since Python 2.1. And another one is PyTest. We also have nose or nose 2, but these are not so popular nowadays. You may see them in some of the legacy code. So first one is the unit test framework. How do we use unit tests? Well, we can, as I mentioned before, it's built in Python, so we can just directly import it without installing anything. So you do the import unit test, and then we can create test classes which inherit from the test case from the unit test. So here in this example, here we import the unit test, and then we inherit our test class, which is the test sum, from the test case from the unit test. So in the actual function, there are a couple built-in methods that we can use for the unit test. So the assert equals, which is to assert if these two things are equal, and again we could put in some comments if the test failed. So if we would like to execute the file, then we put this line here. If underscore name, note that these are two underscores equals to main. This means that if you execute the script alone by running the Python test py, let's suppose this test is called test py, as a command line, then it'll call this, whatever is underneath that. Let's see a question. Do we need to install the unit test package? Yes, as I just said, the unit test is built into Python, so we don't need to install everything. We just need to import it. All right. So when you would like, for unit tests, when you would like to do something prior to the test, such as like set up some data or like functions, you can use the setup method. And if you want to clean up after all the tests are done, such as like delete some content or like reset some configurations, then you can use the tear down method. So the example of above example looks like this. We do the setup and we set up for the test cases what is supposed to run, and we do the tear down. We clean up after the tests are run. And then we have like different test cases to test different things. The unit test has like many built-in methods for quick testing. For example, the assert equal, as I showed above. There could be other things like assert in or like assert false, assert true, all those sort of stuff. A detailed list I posted in the reference list below. You can also test if an error occurred in the code, like test expected failures happens using the self.assert rises. So here's an example. You do this with self.assert rises type error, and whatever is executed done underneath that, when it throws the error, it should capture that. If it doesn't, then it'll raise an error saying this type error is not raised. So here, another framework I would like to cover is a PyTest. So PyTest is you upon the unit test. So all your unit test code can work seamlessly with PyTest. There are quite a few different benefits for PyTest over the unit test. So the PyTest cases are a series of functions of Python file, like starting with the test underscore. Well, this pattern is also true for the unit test. So this one is function-based rather than the class-based. PyTest also has support for building a third statement inside the special self.assert methods from the unit test. As you can see, this one is back to how we write the Python test from scratch. The third one is it also supports for like filtering for different test cases. It can rerun from the last failed test, and it has better debug information, and it has a really good ecosystem of hundreds of plugins to extend the functionality. So like a very good, it can output a really good report, or it can show a really detailed debug information, or it can run all the tests in parallel really easily. So as I showed an example here, it looks quite similar to when we are writing all the tests from scratch. Also, it can assert the exception similar as the unit test, which is when you do the with, you do the pytest.rises, and you do the error here. So that's a quick look at the PyTest framework. Now let's talk about the test file structures. There are basically two ways that you can structure your files for your project. The first one, which is also the preferred one, is to have all your test files inside the test folders and have your test folders outside of the application source code. Another one is to have the test folder inside your source code. And then the test folder is, let's say, like if you have a few different source code folders, each folder could have its own test folder and test files. Test execution. So after we write all of the test cases, how do we execute it? Well, the first concept is the test runner. The Python application that executes your text code, checks assertions, and gives your test results in your console is called the test runner. How do you run your test in the command line? To run the test, you can do this Python-m unit test and test. Suppose your test file is called the test.py. You don't need to put the .py here. You just put your test file name here. And also note that you can run specific test function with the dot. Basically, the test class test method. And you can also add the -v flag to print more info in the console. So you can do the Python-m unit test -v test. You can also put like multiple v's, so like -vdd test for more detailed info. And finally, you can use auto discovery for patterns rather than the file name. So basically, you put the discover instead of test. And it can detect and run all the files named as test_something. So for example, test_sum_py. Do you have questions? Mocking, yes, I'm going to talk about that later. Okay, seems like we're good. All right, so how do we read the test output? Well, when we run it, it's supposed to output something like that. The first one here in this line, it has a capital F and the dot. Capital F means the one test is failed. The dot means one test passed. So when we have a fail, it's going to print some of the, it's going to print the information of how it failed. So here in this line, it says failed, test list fraction. This is the function name, which means this function failed. And it's inside this test.py file and inside this test_sum class. Here is some traceback error. So basically, this line says in line 21, in this test function, we have this assert equal result equals to 1. And this something went wrong because the result is a fraction of 9/10 is not equal to 1. So that's how we read it. And underneath here, it says run 2 tests in this amount of time. And it failed. Failure is equal to 1, which means 1 test failed. So also note that you can configure your IDE to run the test too. And details in the reference links for how to configure that. The next one I would like to cover is the fixtures. So the fixtures are the data that it creates as the input. It's common practice to create some fixtures and reuse them. How do we test if an exception has been raised? Yes, I covered that before, which is here in the unit test, we just do with self.assert rises. And in the PyTest, we can do with PyTest.rises. That's how we test it. Okay, let's go back to the fixtures. You can write your own code, own function from scratch to create fixtures, or you can use third-party packages. the PyTest framework has built-in functions to mark your functions as fixtures. And if you're a web dev, then Factory is a very famous package for creating fixtures with ORMs, basically, which means to initiate some data in the database. And another concept is mocks. There were questions asked about mocking. So basically, mocks are another important part of unit testing. As of 3.3 and later, mock has become a standard library in Python as well. So you don't need to install that. You can just import it as unit test.mock. Since unit testing is to test a specific function, sometimes we don't care about the other parts of the function, and that's why we mock them. We can also use mocks to control your code's behavior during the testing. So in other words, your test executes predictably only so far as the environment are behaving as you expected. So here are a few examples. We use the state time library a lot because we can use it to get like different days and times, weeks, and that sort of stuff. So let's say we use this state time to create Tuesday and Saturday. And then this is how we mock it. We set this state time to be a mock object. And here we have this function called checks if it's a weekday. Basically, it gets today, which is the datetime.today. And note that the Python datetime library treats Monday as 0 and Sunday as 6. So when we return if today is between 0 and 5. Now, let's run it. Basically, when we have here is how we trick it, how we mock it. We set the datetime.today.return value to be Tuesday. And then when we check this function, it is actually Tuesday. And then we wanted the return value of today to be Saturday. So basically, we mock today to be Saturday. And then we run it, it's not weekday again. So like we checked the today's return value in the function, and this function checks it. It can basically produce different behavior. That's how we mock certain stuff. So here are a list of the references. These aren't really important. I strongly suggest that you take a look at all of them afterward. So you can think this as an example. A lot of these are like cheat sheets. So basically, after reading all of them, you should have a general understanding of how everything works and what are the built-in methods to them. And in the future, in your work, if you forgot anything, you can always refer back to these cheat sheets or these articles to refresh your mind. All right, before we go to the next section, do we have more examples? Questions? What exactly does mocking do? Perfect. So the mocking basically controls what a function returns or what a variable or what a class returns. So basically, we mock to control your code's behavior during the test. So let's say like you have a function checks if it's a weekday for today. And in your test code, today is Sunday. It's always going to produce Sunday so that you cannot test it. Think of our goal as when we know the input, we should expect a certain output. And the date for today is if we know the date for today is like Sunday, we know it's supposed to be not to be a weekday. And if it's a Tuesday, it's supposed to be a weekday. But we need a way to control that. And here, we are using mock to control the date. And then when we test the functions, we know for certain input, we produce certain outputs. That's why we use mocks. All right, looks like good. Let's go to the next section, the type annotation. As we all know, Python types are really flexible, which means weakly typed. But this sometimes can create some confusion in the code. Since Python 3.6, we have a new type annotation, and Path 526 describes it in full details. I will cover this path thing later. So let's look at an example here. We have age, which we annotated to be an int, and it equals to 1. So here is a syntax. From those background from Java or like C++, those are strongly typed languages. You have to always mention the types at the beginning. Whereas in Python, since age is equal to 1, this age variable, we can actually set pretty much everything to it, like strings or like int or whatever. And then we annotate it to be int. So if we put something weird here, we know that is against the annotation. In Python 3.5 and earlier, you can use a type comment instead of the type annotation. So for example, we use comment and in the comment we say type is int. And you don't always have to initialize a variable to annotate it. You can just give it int and it's okay, there's no value. But please don't do that, that's not good. Okay. All right. So you can also annotate variables, function, classes, and pretty much everything. Basically, this is how you annotate the function. In the function argument, we have this function greeting and it has argument name. And we annotate the name to be a string. And for the function's return value, we use this little symbol to annotate it as a string value as well. So here are some of the built-in types that you can use. So this typing is also a built-in library. And there are quite a few different types that we can import it. Lists, sets, dictionaries, tuples, and pretty much everything. And then similarly, we can just annotate our variables and functions to different types. For example, like int, floats, booleans, or list set, or dictionaries, tuples, and everything. That's how we annotate it. Note that you can also create custom types for your code. So for example, from typing, this time we import the new type, and we create a new type called user ID, and then we can use it. Combining everything from all above, here is how we annotate a function. So we could, for example, have the send email function, and we have multiple arguments, emails address, senders, CCs, subject bodies, those stuff. And how we do that is we annotate each argument to be some of the types. So later, like 5 months later, when we come back to this function, we don't need to read what's going on. When we look at this annotation, we know what are these variables. So yes, a question is, if we don't annotate the Python return strings, yes, the annotation is in Python 3.6. And if we don't type annotate anything, the functions would just run as it's supposed to run. So for example, Peter and Keegan showed you how we run functions, we run classes. Without annotations, everything works as expected. The annotation is just, let's think of it as a node. So basically, your node, your argument will be returning this, and your type is this and that. So it basically is just a node. Whether that you have your annotations or not, it wouldn't interfere how functions or classes would run. It just showed you these imports to have these types. However, there are third-party packages that can check the annotation, and if the function doesn't return what the annotation said, it's gonna raise an error. But that's like some third-party package checks. I will cover them later. All right, so here are a couple other references for the type checking. And again, please read that as homework afterwards. Do we have more questions? Okay, yeah, after annotation, if I assign a string to an int, will it raise any exception? As I just mentioned, no, it wouldn't unless you have a third-party package that checks it. Note that if you're using like certain IDEs, for example, the PyCharm, if you note it as an int and actually return a string, when you configure your IDE, it could catch that for you. But the Python programming language itself can catch that unless you specifically use third-party packages to do so. Is there a way Python will convert the data types to annotate text strings to int automatically? Yes, some of the IDEs can do that automatically, but it's always a third-party package. Like if you create get some extension to do that, sometimes it'll work. But Python, it doesn't come out. This kind of function, it doesn't come out of the box. All right. Any more questions? What is annotation? Well, this type annotation is just so-called that it's some way that we note types for the arguments, variables, functions, and classes. It's basically a terminology. All right, let's go to the final session, the Python best practices. I've seen so much code with bad practice, like LeetCode, Kaggle, open source projects. And that's why I would like to show you what are the Python best practices. So when you learn something, when you learn like from Udemy or whatever, I don't really think many teachers show you the best practice. And then when you write your code, as a beginner, you write, well, function code, but it's tough to read and doesn't follow the best practices. And when you find a job, your peers are giving you comments about your code and you have to improve. And those could be avoided at the beginning. That's why I would like to cover these best practices for you. All right, well, disclaimer first, this presentation is entirely subjective and is based on my experience and whatever is widely accepted by the Python devs. All Python code is guided by the PAPs, which is called the Python Enhancement Proposals. These PAPs, they are official documents or like proposals from the Python community. And these are the guidelines of how Python should work, how Python should look. The first one is virtual environment. So since Python has many different versions, there are also so many different packages with different versions. It is always best to use virtual environments to make sure the versions are properly isolated. Suppose you have like when you I think buy MacBooks, it comes with Python 2.7. Well, a couple of years back, I haven't bought a MacBook since then. It came with the Python 2.7. Let's say you install the Python 3.8, and then you have two Python versions coexisting in your file system. And when you run your program or project, it could potentially have errors that are super difficult to track and debug and figure out what's wrong. That's why you should always create your virtual environment first and then install your Python packages. And then from that virtual environment, all the package versions are fixed and the entire environment is isolated from whatever you have outside of the environment. And then you should have a predicted behavior of your functions or projects. So basically, there are mainly 3 virtual environments: the virtual main, the anaconda, and the pipette. Of course, there are a few different more, but these 3 are most widely used nowadays. The first one is virtual main. So this is basically the most widely used, especially for like web devs or like any industrial Python development related, pretty much other than machine learning. So there's another third-party package called virtual wrapper that makes everything much easier to use. So with the virtual wrapper installed, you can simply use make virtual to create virtual environment. You can use work on to activate the virtual environment and deactivate to deactivate the virtual environment once you are done with your project. And you can use like set virtual project to set the path. So when you activate your environment wherever you are, it automatically goes into the virtual project root path. I think is a question. What is the difference at using each one of the environment? Yes, that's what I'm gonna cover. Anaconda. Anaconda is most widely used in the AI areas, for example, machine learning or data science, because it has integration of many packages. So when you install Conda, it already installs pretty much all the basic libraries you need to use. So it's much easier to use. Whereas virtually, you have to hit install everything yourself. And the commands are slightly different for Windows and Mac. So some of the commands are conda create -n your invariant name and conda install your package name instead of pip install. Note that you also do the pip install package name, so it'll also install it. And you have to use source activate and source deactivate to activate and deactivate the environment. Okay. What's my personal preference? Well, I use virtually at work and I use Anaconda for my machine learning projects, technical computation, that sort of stuff. And Anaconda actually works much better on the Windows machine, whereas virtually it's a little bit different. Virtually works very nicely on the Linux machine. What is source? Well, it's just the keyword that you have to use. It doesn't mean anything, but when you activate for Anaconda, you have to use source activate and then your environment name. Let's say in the first line, you create an environment called Python 3.7, and then when you activate it, you have to use source activate Python 3.7. That's how it works. The question is, when I'm working with Python, I always get troubles from installing multiple versions of Python in one PC. Do you have any suggestions regarding to this? Yes, that's exactly why I'm talking about these virtual environments. So you should use any of these 3 to create virtual environments. So how does it work? Is that you create a virtual environment first with your Python version. Let's say you have a Python version 3.3 and you have a Python version 3.7, then you should create 2 environments. The first one is Python 3.3, and the second one is Python 3.7. And each of the virtual environment, you should install the packages for those environments. Let's say you have a project calculator for Python's that was written by Python 3.3, then you should install all the packages for this calculator project inside the Python 3.3 version environment. Whereas if you have another project of, let's say, machine learning project from Python 3.8, then you should install all the Python 3.8 versions and packages inside this Python 3.8 version environment. Can we use Python to create virtual environments? Yes, you can. All right. Okay. I've covered the virtually and anaconda, and the last one is pipenv. The pipenv is a new standard Python packages. It's a combination of the pip and the virtually. And it also has a dependency version lock. So this is quite important, where some of the package versions only work with particular version. So most of the time we need to lock it. Some of the pipenv command lines are pipenv shell, which is to create a virtual environment, and the pipenv install package, which is similar as conda install and pip install. And we can also do this pipenv install -- dev, which will install for the dev environment. Can we do this through a third-party software? What do you mean? When we are creating virtual env. I don't really understand the question, but all these packages are third-party. So virtually or Anaconda or pipenv, they are third-party packages. So you have to install them first. Well, I have documentations in the reference links for all of them. So feel free to read them later. Do I have any more questions regarding to these virtual environments? All right. Next, I would like to cover the code structure. Keegan has already shown a code structure before, but I would like to cover some kind of like the entire project code structure. So basically, for your project, it could have a source folder which contains all the source code of your project. And then, as mentioned, the test folder, which will have all your tests. Most of the time, you should have a README folder, a README file, which illustrates how your project do, how to run your project, and if it's an open source project, then how to contribute. Sometimes you should have the license if it's open source. And you should always have the requirements.txt, which lists all your packages that you use for your project. And some of the time you should have a documentations folder, which will have documentations for your project, like how to do stuff. If it's let's say if it's a web app, then how those API will work, that sort of things. And the last one is setup.py. If your project is a third-party package and you can distribute it, you need a way to set it up, basically to install it. So that's why you should have your setup.py file. Okay. So we have a question. What is a virtual environment on Red Hat Linux? So this is entirely dependent on what you choose. The Red Hat Linux is just a Linux distribution. And I think what Python came from that should be the Python 2.7, I think, I can recall. And then you still have to install any of these virtual environments. Note that you should just install one of them, don't install all of them. So basically, whatever Linux version, like Red Hat Linux or like Manjaro Arch Linux or like Mint, whatever, those are the operating system. So that the Windows or Mac. And these virtual environments, you have to install them separately. How does Git get involved in this code structure? Well, it doesn't. The Git, when you initiate your Git for your project, it'll have a hidden file called like Git something and a Git ignore if you put stuff there. So those things will not be shown here. These are just the Python, the project structure in the point of in the Python point of view. When you have Git and those Git directories and configuration, they are hidden files. So I didn't show that because those are automatically created. What does pip install --dev do? It'll install a dev tagged version. So basically, like if you are a web developer, most of the time you have like multiple environments that you have. So for example, the development and the production and staging. And then you can use pip to install different versions of your environments. So it's pretty handy. I have detailed information in the reference list. You can take a look later. All right, the format of Python. This is the fun part. So the formatting, linking, and typing. The format is how you write your code. The linking is a way to check your code's format. And the types are the annotation that we just talked about above. So there are basically two things that you must remember. The Path 8, which is the official style guide for Python code. I've posted the link here. And a black is a third-party package, which they call themselves the uncompromising code formatter. So what black does is it can format your code so it's more readable and it looks very nice. And it's one of the official supported formatter for VS Code. So you can actually use it in your VS Code. I think Python can use it too. And also, Django has accepted using black as formatting as of May 10th, 2019. So if you're a Python web developer using Django, you definitely should think about this third-party package. Note that, remember, the code is executed by machine, but it's read by human. That's why we need to format the code really nicely so it's readable. And that's why this formatting becomes super important. So let me just quickly show you an example. Let me make this a bit wider. Here on the left is a badly formatted code, and it's like super long, it's tough to read, and it's probably tough to decode. And on the right, it's a good formatted code, which was formatted by black. As you can see, it's nicely formatted short lines, but a little bit longer. Well, we don't really care about the code length as long as it works. So whether it's horizontal or vertical, they both work. But having it vertical, it looks much nicer and it's really easy to see and find certain stuff. So for example, I could easily see this patience is 3 and verbals is 1. And when you are testing with different stuff, you can easily just comment out a line to see what's going on. So it's really nicely, like for example, this factor is 0.1. What if we get rid of it and use the default one? Just comment this line out. And here on the left, what you have to do is you have to comment out this entire line and copy and paste it below and change it to something. So, by having a vertically aligned format, it's really easy to work with and easy to read. All right, let's keep going. The indentation. Well, Python recognizes both space and tab for indentation level. And Path 8 suggests to use space. And most of the time, we use for space, the indentation level. And you should never mix space and tabs. Strings. This is quite a heated debate whether use single quote or double quotes. So recall that when we have string, we can use a single quote or double quote. They are equivalent. You can use which one depending on your choice. However, Black suggests to use double quotes to reduce confusion because the double quotes are used by the English language. And it's really nice to use, let's say, like you have double quote sentence and you have some like single quote inside of it, and you can just type like normal. Whereas if you use single quote, then you have to use this backslash to escape the single quote, so it doesn't cut it off. But most of the developers actually use single quote because it's easy to type. Whereas if you use double quote, you have to press Shift key, which which doubles the keystrokes. So when you are using Black actually has already thought about this because it's just being debated so hard, and you can use this double dash skip string normalization to stop Black from formatting your quotations. Do I have any questions? Yes, I always run into issues with virtual name, especially with TensorFlow. Yeah, because it's quite tricky, and on Windows 10. Yeah, it's pretty tricky to install TensorFlow on Windows 10, especially with the GPU version. Luckily, I did that before, and I have an article of instructions on how to do it. So yeah, you can take a look at that, and hopefully it can help you install that, no problem. Okay. Difference between print and PP print. That's a really nice one. So the print basically just prints out thing. And actually, let me just show you a quick example. Let's let me add code here. So let's say that a dictionary is name is person and title is developer. So when we do print, just print this. Oh, please. That's a silly mistake. Okay, it'll just print this in the horizontal line. But if we do use PP print, typos. Okay, that's it. Let's do this. What? Okay, so here. Jeez, so many typos. Shouldn't do this anyway. All right, so when you're using a print, it's just gonna print everything in the line, in the really, really long line. Where this PP print means it's a PP print, where it's gonna print everything nicely, so it's much easier to see. All right. If I suspect my code has space tab issue, how can I quickly address that? Okay, yes. So most of the IDE should automatically detect that. If your code has a mix of that, then your IDE should detect that. And when you run it, I think the Python interpreter also detects that and throw some error of mixed of space and something like that. So you shouldn't need to worry about that. All right, let's continue. I've just covered the strings. Okay, and the line length. Yeah, Type A suggests all lines to be limited to 79 characters and 72 characters for comments. Well, 79 characters is a pretty small number because back to, let's say, 10 years ago, small terms are really tiny, like 15 inches, 19 inches, and 13 inches, like those small monitors. So that's why we need to limit that to 79 characters. But nowadays we have like extra long monitor, extra wide monitors, and we have like big monitors. We could even have like 50-inch monitors. I'm currently using a 34-inch ultra wide monitor, so that wouldn't be a problem. Most of the companies use line length. Well, not most. Many companies use line length of 100 to 120 characters because that'll reduce the lines of code significantly. However, Black suggests use 88 characters per line. So, well, it's just a company preference. Line breaks. Part 8 suggests using line breaks after binary operators for readability. So for example, you should put your like plus minus line here at the beginning, rather than having them at the to the right of the variables. And also, we surround the top level function and the class definition with two backflies. What that means is that basically when you do let's say this, when you do your like import datetime, then you should give it two extra lines, and then you do your depth get week, and then you're gonna give it some extra lines. That's what it means. Okay. Just this up. Okay. All right. 9 bricks. Oh, where are we? Okay, here. All right. The imports. Yeah. When you import something, you need to be explicit, which means you should do this from subprocess import popen and pipe, like from something import something to be explicit. And all imports should be on the separate lines. So you should do import OS, import sys. Well, you can do import sys, comma OS, comma whatever, but you should, when you are doing a single import, you should use separate lines. And the imports order should be import the standard built-in libraries first. So for example, import OS, import sys, and import related third-party library. And then import your local library. Let's say you have a web app that you have. Then the first one is to import OS, import sys. And the second one is import, let's say, Django, because it's third-party related package. And last, you should import your web app libraries. Let's say like you have a user library, then you should do the import user. So that's how it's getting ordered. And what if there are so many classes you have to import from one single package? Well, you should do this. So from, let's say, secondary module selection, import a whole bunch of different model selection tools. So like k-fold split or stratified k-fold split, that's how we do it. Note that I've seen like people are like writing super long lines, it's also working, or using a backslash here, it also works, but this one looks much nicer and easier to read. And the last one I want to cover this is the call chains. So this relates to the web development. Some of the popular APIs like ORMs, they use call chains. So here is how you can use it. I am sure Daniel and Frank will cover more of this in the week 3 sessions. So basically, when you do this, you do a session.query and you do this dot filter dot order by dot all. Basically, this is call chain, which means you execute that first and execute that and execute that and execute that. Everything is linked together. It's called a call chains. And this is how you should format it. Okay, and up to this point, these are the ways of formatting. You don't really have to like remember all of that at the beginning, but if you install the Black package and you let the package format it for you, and then once you written enough Python should be like remembering all of that really, really easily. We got a question. So the third party package will be loaded after virtually after loading the conda. Well, you're mixing these two concepts. The virtual environment, conda is one of the virtual environment. Another virtual environment could be virtual name. So basically, so the order is that you should first create your virtual environment, whether you're using conda or virtual name. Well, the virtual name is the third party package called virtual name, which is equivalent to conda. And then after you've created these virtual environments, you should install your third-party packages. Do you have any more questions? What is ORM? It's mapping between the programming language to the sequels. So I'm sure Daniel will cover that in the next session, week 3. All right. I need to be speeding up. Long strings. So most of the time we are producing like messages, especially like you want to output some messages, whether you are like doing your machine learning projects or web apps. So when you are having long strings, how would you do that? You can write it super long, or you can have a long string break it up to a few lines. So here are a few different examples. Let's say the first one is to break into a few lines. So this is how you do it. And it'll work nicely like this. And then you could use triple quotation mark. But this is going to create some line breaks. And the last one is, again, you can break it into different lines, and then you use plus sign to join them together. However, this will create more strings. So these are the output of what it looks like. All right, naming convention. This is actually really, really important because we have to make sure the names, they make sense. So please do not use single character names like ABCD, IJK, whatever, because those doesn't make any sense. The first thing is we need to use meaningful words rather than a single letters. So for example, we use user IDs, not like you know. So note that this also applies to functions, variables, and classes, and everything. For example, like we have a function called get user ID, or like we can have a variable called user profile grouped by ID. We don't really care like how long the name is. We need to make sure these names, they have meanings. Otherwise, like 5-6 months later, when you look back into our code and you have to figure out what those single letter variables or whatever means. And this naming convention actually is true for all programming languages like C++, Java, JavaScript, whatever. You have to write meaningful names. Yeah, the second one is function names. The function name should be all lower cases and separated by underscore, like def my underscore function. Unlike Java, where you do the first one is lowercase and the second one is uppercase. That's not the case for Python. Python, you should do this. Yeah, Java use camel case, and you shouldn't use that in Python. And the last one, the next one is a class name. Class name all use capital words all together, no underscores. So you should use that. And the constants, if there are global constants, then you should use all capital words like this. There are also a couple other cases like single leading underscore. This indicates it's a weak internal use indicator. So basically, they should be used internally inside your function, and it should not use in other places. And we also have the double leading underscore. this invokes a name manual for the class attribute. Well, as a beginner, you probably shouldn't use this very often. But if you're writing some like packages that when you do some methods underline, then you should definitely use the double underscore. So as actually Peter showed you before, the double underscore length and the double underscore equal, those are the double underscores. All right, white spaces. White spaces is it's just like makes your code looks much easier, and sometimes it makes your function work. So if you put the white space wrong, then sometimes it won't work. So for example, here are a few different cases how you use it. Basically, after the comma, you should use a white space. And note that this one is a tricky one. So this means it's a tuple. And then the first one is 0. So you have to make this 0, comma. If you get rid of this comma, then if you use a parenthesis 0 parenthesis, it means it's a 0. So the type is different. So this one is tricky. You can actually play with it. Yeah, and these are just how to put it the right way. So basically, if you have a variable definition, then you should you should use a space around your operators. And if you're having like comma in your line, then you should always put a space after that. A detailed explanation is in the PEP document that I linked later in the documentation in this documentation. And the doc strings. So the doc strings, you should always write it for all public modules, functions, classes, and methods. And we use triple quotation marks for long strings and comments. And PEP 257 describes what a good doc string looks like. And so the function annotation, as I just showed you earlier, and PEP 526 describes all the good function annotation ways that you should use. And so does the 484 use the type hints. All right, so as a summary, here are some of the helpful tools. First one is Black, third-party package. Again, Black is used. This is source or iSort. Is sort imports alphabetically and automatically separated into sections. And Flake 8, it actually checks the styles. So basically, it helps with linting. My type is static type checks. So as somebody asked before, like, what if my type annotation is different? Well, this my type actually checks it. PyTest covered that before. PyTest cover. This is a third-party package that will generate a nicely formatted test code coverage report. And also, you should think about using the Git hooks with the pre-commit Git hooks. So I'm not gonna cover that here because this is a long topic, but you can simply do a Google research and see the articles there. Next one is a cookie cutter. It's a project template. It's really nice to use. So basically, if you're, let's say, a web dev working on like multiple web projects, then the cookie cutter can simply generate a profile, a project file that just looks like the project code structure like this. Of course, it's defined by you. So basically, it's really easy way to produce something like that. The last one is a couple packages, PySnoop and PUDB. You can try them out and see their description. They're really nice to use. So here are the references that I was talking about: the PEP 8, 257, 526, and the Black Code Style Guide. And these links, you should definitely take a look, like read them thoroughly. You don't really have to like remember them immediately because there's so much info, but you should definitely be aware of what's going on and what are the best practices looks like. So in your future, when you're writing the code, you should respect those best practices and write your code as good as possible. So when you actually are getting into the field, working as a Python developer, then your peers will say, you have to rewrite this because your format looks terrible. And here are some links for setting up the environments. Basically, those are my blog articles. I've set up environments with pretty much all of the virtual environment packages. So I wrote articles about them. So if you would like to use them, you can take a look. Yeah, it's about time, and I have something to say at last. So whenever you choose to become a software developer, know that you may have many questions, and sometimes it's really difficult to find somebody to ask. So note that Google is your best friend. Before asking any questions, just do a simple Google search first. You will pretty much find whatever result you need. And then Black is also your best friend, as I mentioned many times. So make sure you follow the Python best practices. And when you write any code, always make sure to test your code. And yeah, good luck on your career. It's 4 p.m. So I guess that's probably the day. And if you have any questions, feel free to ask in the Slack channel. And for those web development related, like I saw people asking what's ORM and what's those things, database, that kind of stuff. Daniel and Frank will cover that definitely in the next session, week 3. So feel free to ask around at the time. And yeah, wish you all the best.